Good day everyone, this is Vishaan Padaw of 11th STEM in Providence. Today we'll be learning higher order derivatives and I will be showing you examples. Hello everyone, for this video we're gonna work on finding higher derivatives. So we'll go over different rules of taking up a function and find its derivative. But after going through that process, notice that you simply get just another function. So what's necessarily stopping you from taking a derivative of a derivative? And what we'll find is, there is really nothing stopping us. We can go ahead and take a derivative of a derivative. So let's go and pick up some notations you'll see as we're doing higher derivatives. The derivative that we've been doing is essentially just the first derivative. So we go through maybe one of our rules and find the first derivative. If you take the derivative of this derivative, you'll call it the second derivative. And you often see two tick marks next to the function. Now, if you take the derivative of the second, you'll have the third derivative and put 3 tick marks. And if you'll get the derivative of this one, you just kind of abandon the tick marks and say we're at the fourth derivative, or f to the 4 of x. And you could keep on doing that process as long as you want. In terms of the derivative operator, you can also express how many times you take a derivative. So here's our familiar derivative operator, d over dx, and here's how it looks like of the second derivative. Notice how I added the 2 at the top and 2 at the bottom. And you can imagine this happening because you have 2 of your derivative operators and starting to stack up of one another. So 2 d's at the top and 2 dx's at the bottom. Okay, continue from there. You could put your third derivative, 3 on the top and 3 on the bottom, and your fourth derivative, 4 on the top and 4 on the bottom, and again continuing on from there. Let's go ahead and find, let's say for example, the 4 derivatives of f of x equals 4x to the 5th minus 3e to the x. So let's start finding the first derivative. So using the power, you bring down the power, you get 20x to the 4th minus 3ex. And then, so why stop there? Let's find another derivative. For the second derivative, we have 4, bring down 4, we have 80x cubed minus 3ex. Now let's find the third derivative. Again, bringing down the power, we'll get 240x squared minus 3x. And for the fourth derivative, you'll get 480x minus 3e to the x. Now, what the example shows is that when we're working with polynomials, that power will just keep on reducing by the time you take a derivative. As you can see, 5 makes 4, 3, 2, and so on. But there do exist functions like 3ex that just don't get simpler as you take another derivative. Another example would be f of x is equal to 2x squared plus 1 multiplied by 4x squared plus x. I recognize that I have 2 functions in here, so I'll call this first function as u and the second function as v. So how can I do my product rule? We'll have uv prime plus vu prime. Now let's see how that one looks like. So the first derivative is equal to, the first function is as it is, so that would be 2x squared plus 1 multiplied by the second derivative, the function rather, of this one, and that would be 8x plus 1. plus the second function, which will be as it is, 4x squared plus x, then the derivative of the first function, which is 4x. Now we can find the dual derivative of this and use the product rule twice. Okay, so I'm gonna call these functions here again as u and v, and apply the product rule for this only. So we'll have the first function, 2x squared plus 1, multiplied by the derivative of the second function, which will be 8, plus the second function, 8x plus 1, and the derivative of the first function, which is 4x. Now for the second, let's call this one again u and v, plus, as it is, 4x squared plus x, excuse me, the derivative of the second, which will be 4, plus the second function, 4x, and the derivative, which will be 8x plus 1. So we have here the two derivative, and all we have to do is combine or distribute the functions as many as possible. So we'll have this 16x squared plus 8 plus 8 plus 32x squared plus 4x plus 16 squared plus 4x plus 32 x squared plus 4. So we have here different x squared. We're going to combine it. 16 plus 32 plus 16 plus 32, you'll get 96x squared. And x's 1, 2, 3 plus 12x, and we have 8 all by itself. So there's two derivatives of the original function, and if you just can remember that with the entire derivative, we're taking a derivative of a derivative, and apply your rules carefully, you'll be just fine.
Good day everyone! My name is Annalyn Salosha and I am from grade 11 Stand A Providence. Today, we are going to determine the second derivative of a function. Let's say our function is f of x equals 3x to the power of 5 plus 2x cubed minus 6x plus 4. We need to start with the first derivative. The derivative of x to the power of 5 is 5x to the power of 4 plus the derivative of x cubed is 3x squared plus the derivative of x is 1 and the derivative of a constant is 0. So 3 times 5 equals 15, copy x to the power of 4, plus 2 times 3 equals 6, copy x squared, and negative 6 times 1 is 6. So our first derivative is 15x to the power of 4 plus 6x squared minus 6. Now, we need to differentiate this expression one more time to get the second derivative. So, the derivative of x to the power of 4 is 4x cubed plus the derivative of x squared is 2x, and the derivative of a constant is 0. So, 15 times 4 equals 60x cubed plus 6 times 2 equals 12x. So now we have our second derivative of a function, 60x cubed plus 12x.
Good day everyone, my name is Samantha Nicole Ruiz Tan and I am from STEM A11 Providence. Let's have another example of a function and take a few derivative of that one as well. This one is 3 times the square root of x plus 5x. And if you want, you can imagine, say, the square root as x to the 1/2. It usually makes doing the derivative a little bit easier. So doing my first derivative, out of thinking, bringing down this power, 1/2 would multiply by the 3 now to get 3/2 x to the negative 1/2 plus the derivative of 5x would be 5. So that is our first derivative. Let's do another derivative. So this is the second derivative. And I will bring down this power. So now I have negative 1/2 multiplied by the positive 3/2. I get negative 3/4 x. And this power will be reduced again. So I have negative 3/2. And the derivative of a constant is now gone. So that is just 0. So that is our second derivative. Let's find one more of these things, and this is the third derivative. And this third derivative, now think of taking this power, bring it down and multiplying at the front. Negative times negative, it will give us positive 9/8 x to the negative 5/2. So that is our third derivative. And we really could continue on from there, just continuing bringing down the power. And this one is kind of neat. You will notice that the sign actually alternate. We get as a negative and our derivative here, this will be positive, and the next one, this negative, will come down and we will get another negative in there, and it just keeps flipping back and forth.
On the pages is the answer to a never-ending story.